This video is going to cover Unit 29, Section 1 and Section 2, Pyramids and Cones. Okay, a pyramid is a polyhedron. Now, a polyhedron is very similar to a polygon, where a polygon is a many-sided object, but it's two-dimensional. A polyhedron is a three-dimensional many-sided object. So a pyramid is a polyhedron. And the base of a pyramid, so we have an example right here, the base of the pyramid can be any polygon, really, for that matter. Could be a triangle, a square, rectangle, pentagon, hexagon, octagon, all of that stuff. Mainly, what I will deal with will be rectangular bases and maybe a triangle. Something that you can very easily calculate the area of. Hexagons, you can calculate the area of those, but it's a bit trickier, and that's really not part of what we're trying to do here. Now, the altitude or the height is from the vertex down perpendicular to the base. Now, remember, a regular polygon was a polygon that had all of the angles were the same and all of the sides were the same. Oh, let's see here. Then we've got a cone. Yes, from the movie Coneheads. If you haven't seen that movie, it ain't that big a deal. So a cone is a solid figure with a circular base. Okay, so here's the base is circular here, and once again you have the height is perpendicular to the base going from the vertex down to the base. Okay, that is really all they're doing in Section 1 is just introducing you to cones and pyramids. Now, Section 2 deals with volumes of pyramids and cones. So the formula for the volume of a pyramid and a cone is the volume is equal to the area of the base times the height. This is very similar to a prism and a cylinder, but the difference here is we're going to take that now and divide that by 3. So the area of the base times the height divided by 3. Now the area of the base is calculated differently for this and for this. For this one, it will be width times length and then times height divided by 3. For this one, volume will equal the area of the base, which we know as pi r squared, times the height divided by 3. So the two bases are calculated differently. So let's run this through here. Let's say that this has a length here of 8, and then this is 6, and let's say that the height is 12. Now let's calculate the volume of that pyramid. So we've got area of the base, so that's going to be 8 times 6, and then we're going to multiply that by the height, which is 12, then divide that by 3. Okay, so what I'm going to do here is I'm going to reduce already. 3 goes into 3 one time, 3 goes into 12 4 times. So this just becomes 8 times 6 times 4, which is 192. 192 inches cubed, if all of these were inches. Now let's calculate the volume of this cone right here. Say it has a radius of 7, and let's say that the height is, let's keep that 711 thing going. 711. Okay, so the volume would be 3.14 times 49 times 11 divided by 3. So I can't cancel this out very quickly like I could the other, so we'll do the whole thing. 3.14 times 49 times 11 in the numerator. In the denominator I have a 3. So the volume of this figure is 564.15 inches cubed. I prefer inches. I definitely prefer inches to centimeters. That's for sure. Okay, so let's take a look at, see if there's any examples in here that might be good on 721. 721, compute the volume. Okay, that one's too easy. They don't even give you the length and the width in number 7, they just tell you what the base is. Okay, let's look at number 15. A vessel in the shape of a cone. This vessel contains liquid to the depth of 12.8 centimeters. How many liters of liquid must be added? Oh, this is an interesting one. I think I've seen this one. Okay, so let's find out what the volume of the entire cone would be first. So we have a diameter of 15 centimeters. I think we have plenty of room. I'm not going to draw the figure. It's right there on page 721 near the bottom. It's the only figure on the whole page. So we have a radius of, what is that, 15? 7.5. We have a height of 18.2. So let's find out what the volume of the entire cone is first. So that would be 3.14 times 7.5 squared times 18.2. All that divided by 3. Okay, fraction bar. 3.14 times 7.5 squared times 18.2. Denominator 3. Okay, so the volume of the entire thing is 1,071. Since it's well, let's just round it to 0.5. That's good enough. I was going to go all the way with it, but all right. Now let's find the volume that is already filled. Okay, so this is an important part right here. We're going to need that. So let's find out what the volume is already filled. So we've got a diameter of 10 centimeters. So that means that the radius is equal to 5. The height is equal to 12.8. So let's write that. Let's just do this over here. I don't really want to waste this part of this paper over here. So 3.14 times 25 radius squared times 12.8 divided by 3. .14 times 25 times 12.8, 30, let's see here. So that is 334.9. All right, so then we just simply subtract this, or subtract this from this. So 107.1.5 minus 334.9, and we get 736.6. So this is what would still need to be added to that to fill it up. How many liters of liquid must be added to fill the vessel? Okay, so it says liters. How many liters? Okay, so what we need to do is our units that we have here are centimeters cubed. Okay? A cubic centimeter is 1 milliliter. Okay? So 1 milliliter is 1 cubic centimeter. 1 liter is 1,000 milliliters. Okay? So 1 liter is 1,000 milliliters. So let's turn this over here real quick and we'll do that. You can see some of it bleeding through. Should be okay. So 1 milliliter is equal to, or no, let's do it this way. 1 liter is equal to 1,000 milliliters. So what I have, let me peek over here real quick, 736.6. So I have 736.6 milliliters. I'll put that over 1. Now, what I need to multiply that by is I need liters in the top. Or that should just be a 1. I need liters in the top and milliliters in the bottom. Because remember, the milliliters need to cancel with the milliliters, and liter should be the only thing I have left because that's what it's asking for. Well, so let's put a 1 right here and a 1,000 right there. 736.6 divided by 1,000 is 0.736. And the unit that we have on that is liters. So that's how many liters it's going to take to fill that up. So we have to, not only do we have to find out, do we have to calculate the volume of the cone, but remember, all of the units that we're given are centimeters, so what we get is cubic centimeters when we're done. And they're asking for liters. So we need to know how to convert cubic centimeters into liters. Remember, always remember, 1 cubic centimeter is a milliliter. And milli means 1,000. So 1 milliliter is 1,000th of a liter. So therefore, 1 liter contains 1,000 milliliters. And then we set up our unit analysis in this way so that we can convert our known number that we have. And since milliliters is in the numerator here, we need it in the denominator here to cancel out. So that means liters must be in the numerator here. And it's 1 liter for 1,000 milliliters. And that shows me that I need to divide. And then 1,000, that's just a movement of the decimal 3 points to the left.